good evening, everyone. My name is Stefan Hac, and I'm a senior data scientist here at Foursquare. And today's lectures was motivated by my first encounter with industry data scientists. I spent more than 5 years working in academia and academia-related projects, and I was hired by one startup to build them something ML related. And I'm proud to say that we did a really good job and built something, but as a first experience, we didn't know how the data science in the industry works and what should we actually do. So we put everything in production, and 3 years down the line, we had to update our model with new data, and we did not do anything in a reproducible manner. So we were stuck for about 6 months trying to reproduce something that we built into. So this talk is motivated about this. How do you, when you are starting your ML project, what simple steps should you do to make yourself succeed in the future? Let's talk first about Foursquare. What do we do here and what our data science team do? I work in the movements team, so we are translating raw pings, and you can imagine that the signals are not perfect. There is a lot of noise. So you can't think in advance about everything, and you need some kind of ML to solve this problem. We have 3 pillars of how we are solving our problems and what makes Foursquare great. First, 2 pillars are people. We have a really good engineering team comprised of data engineers, software developers, DevOps and MLOps engineers, and they make the classical algorithm part of our algorithms. Then we have researchers like data scientists, data analysts, ML engineers, which create those AI tools that really make our products great, that look like magic. And of course, the third and most important pillar is data. We collect a lot of data. So we have our first-party data, then we buy data from other providers, third-party data, and then there is also metadata, which is collected through different government agencies, for example, census data or demographic data. So I'll start first. I just want one disclaimer. So this talk is for a general audience. So some stuff might be really basic, some might not. I'll start first talking about what is machine learning. And somebody would say, just take algorithms and mathematics. And a lot of people tries to do that, and you come up with something weird like this. It usually happens if you don't know really well algorithms and mathematics. Now let's be a little bit more serious. What's the difference between traditional programming and machine learning? I'll do this on an example. For example, we have an ingest pipeline that takes the data from the devices and stores in our database, and that is a classical algorithm from traditional programming. So we have data, we have some rules. For example, rule can be delete the duplicates, store the data like this, and then you apply a computer or a computer science to it, and you get output as at the end. Other kind of problem which machine learning solves is something like this. So we have ground truth data from our 1P data. So we know what the raw pings are, and we know where the people are going or where are the check-ins. And we want to create rules that figure out from our raw pings where the user went. And we do this in a machine learning manner. So we don't create rules ourselves. We apply machine learning on our data and the outputs, and the machine learning spits out the rules or a computer program. So this is like a simplified difference between traditional programming and machine learning. So somebody might ask, what is deep learning? Because that's also a term used. So imagine machine learning, but with neural networks on top. So for example, we store our data in a graph, and a graph is a really expressive data structure. And then we can use and leverage, for example, graph neural networks, which create some representations of that data, and you can have really cool insights. For example, you are looking at people who are visiting McDonald's, and then you can do some kind of edge regression and suppose what's the next place that they're going to see. And you can, for example, in that manner, if you have that knowledge, you can target some kinds of ads to those people who are going, for example, to McDonald's. So that's like machine learning, deep learning, and traditional programming. And then there is a term AI, which is also used. So AI is everything that we said. So it's anything that makes machine intelligent, so we can call that AI. I'll just go quickly to some ML jargon that is really often used. So first foundation of ML is data. And when you have some data, you usually need to have a training set and a test set. Training set is something on which you train your models. But some models can learn really well in a manner like, for example, imagine that you're going to a test or studying for exam. And you study like you learn the whole book by heart, and somebody asks you something that comes out from that book, but it's not written exactly. And a lot of models do that, and the student will fail on the test. So because of that, you need to have a set of test questions that student didn't saw but should know from the data. So you usually separate data like that. Then you have features. Those are like what the data has, for example, pings, locations, user ID, or some stuff like that. And then there is a process called feature engineering, where you create features from your data. For example, there are like high-level features. You can calculate how much time a person spent in a location or in a place. Then there are models. Models are actually the decision makers. Those are like the computer programs that are output of machine learning. And then there is two processes. One is called model training. That's how do you train a model. And then a really important thing is model evaluation. You need to be sure when you send your model to production that it works well, but you also need to monitor constantly your model when it's in production for different data drifts. Now, a question for you. Like, if you know something about ML or in general, what do you think it's a goal of machine learning? Okay, maybe on a higher level. What's machine learning for a company? So, for example, a product manager comes. Yeah, those are all what machine learning does, but what is the ultimate goal of machine learning? It's simple: solving business problems with data. There is a large misconception that's usually presented to a data scientist or machine learning engineer. So here's some data, bring me some value of it. And that's a huge rabbit hole that you can stuck in and be stuck in for months. When you're applying machine learning, the fundamental thing to have a successful machine learning project, to have well-defined business problem that you want to solve. So if you take anything from this talk, its goal of machine learning is solving business problems with data. And when you come to do machine learning like this, a lot of problems are gone. Of course, you need data and models and stuff like that, but this is a really, really important thing to have. So let's go on an example how machine learning project looks. It might be a mystery that it's something really complicated, that nobody can do that you need a lot of data, a lot of data science and the machine learning people, that you need a lot of overhead at the beginning of the project so you can be successful. Actually, you don't need a lot to start. You need a well-defined business problem and a person or two, a data scientist or a software engineer or anybody that knows to go through data and see, does this data that I have or does this problem that I have can be solved with machine learning? And this is all good machine learning projects starts with the exploration phase. Go out there and see what tools are out there that can solve my business problem, and can that problem be solved with data? Sometimes we set out to solve a really, really hard problem, but there is an open source model that can solve your problem instantly. So this is the part where you go scout use cases, do some modeling experiments, and have an idea how do you solve your problem. Usually 80% of the problem is solved in 20% of the time. So this part, like this first 20% of the exploration phase, will solve most of your business problem. And I said here, like I was saying, like data scientists, data engineer, ML engineers, there are some misconceptions about different roles. So I took this from, I think this was published somewhere on Twitter or now X. So what's the different roles that are here in like data world and data science and machine learning world? So there are data analysts. Those are the people that are really good with wrangling data and getting insights from the data. And then you have data scientists. Data scientists need to know a lot of mathematics, and they need to know some computer science, but they don't need to be computer scientists. And then you have analytics engineers, which are more build-oriented people. And of course, then on the top you have like software engineers, which are there building stuff 100% of the time. There is no machine learning engineer, but the job of a machine learning engineer and data engineer is quite similar. So machine learning engineers usually push your data science model to the production. And one thing that I want to just say, like, this can be all one person. Sometimes in a small company or in a startup setting, all these roles can be covered with a single person. So you don't need a large team to start a really cool data science project. And this is the next most crucial part of the machine learning experience, and this is experimentation. So you maybe grow your team from a 1 to a 2 or 3 people, or still a single person. And this is the biggest difference between academia machine learning and industry machine learning. So in academia, you can throw everything after you publish a paper, but the biggest part when you start experimenting, so there is something came out from, so a simple model came out from the experimentation, from the exploration phase, and now you want to train that model and refine it. But the biggest thing is you need to do this in a reproducible way. And there are a lot of simple tools. You probably heard about MLflow. This is a simple tool where you can log all your experiments when you are doing your project. So when you grow your team further, you can easily go back and see whatever you were doing. So this is the part that I messed up when I came from industry. I forgot to log everything. So we lost the data, the training data set. We even lost part of the code for training the model, and it was really hard to reproduce it later. And this is the place where you make a decision to go forward or not. The one obstacle when working with machine learning projects is that they can fail. Even you can have a really, really good model at the beginning, maybe that last % that was set up as a goal is not achievable with the current state of the art. So when you're doing machine learning projects, be prepared that you can fail, but that shouldn't discourage you to continue further. And the final phase of a machine learning project, it's an engineering part. It's an engineering phase of the project. And here is where the full MLOps pipelines kick in. I'll talk about a little bit what MLOps pipelines are, but this is the place when you have a model that is production ready and you're ready to present it to the world. You then need the team of software engineers to build the software that will communicate with your model to the world. And let's talk a little bit about this is like an ideal ML project team structure, but it's all like every solution in MLOps should be custom tailored to your project and to your team. But usually you have just about 20% of data science and ML engineers. This is a large misconception that you need a lot of data scientists and a lot of ML engineers. Technically, data engineering and software engineering part is more complex to set up than the ML part. So like here in Foursquare, we have a really good cross-functional team that has a good data engineering and data science team, and we work closely together to make all our models and data pipelines to come into productions. And I should also say, like, the roles on data science or ML related teams shouldn't be set in stone. So some people might work sometime as a data engineer and then as data science, and there is a lot of room for maneuvering and crossing to other roles. And sometimes, like, if you are a really small company, as when I was working in a startup, like 2 people were everything here listed on this. So you don't need a huge team to succeed. I'll just go over quickly on about what MLOps are, and we'll wrap it up after just a few slides, just to give you a taste. And this is like 30,000 feet overview of what MLOps are. MLOps are a really complex subject, but I'll just want to give you a quick taste of what MLOps are. So what are the challenges with ML? In the traditional software development, DevOps, usually deal only with two things. You have two kinds of artifacts when developing just plain software. You have records, which might be code documentation, requirements from product, other technical requirements, and those requirements generate code. Then you integrate your code, get some feedbacks, and then they go back to the records, and that's a cyclic process. And whoever heard of DevOps, this is technically DevOps deals with creation of these artifacts, validation, how do you promote your code, how do you change code, and how do you govern everything. In machine learning projects, the picture is much more complex. For example, we had a new pipeline built in the past year. And that idea came from the experimentation project. Few people sat down and tried to change the legacy pipeline that was in. And then some requirements came in, and we write code for data for wrangling. We had data requirements that came from the records, and then we created some machine learning models, for example, those that snap people to different places. But then a customer came in and said, like, this might not look best, or your pipeline was better. So the cycle came back to the records, and everything needed to be changed. We needed to change our pre-processing pipelines, how the data look, and models generated some new data. Then we gathered more data, and models made some prediction on the data that was previously not seen by the model. And we technically wanted to retrain the model on that same data set, so the whole cyclus was done once more. And you see, like, there are a lot of moving parts, and you technically need to think in advance how do you set up everything. So there is a concept called MLOps. It is a set of best practices that help manage the creation and use of ML artifacts through efficient workflows, collaboration, and tracking. And this is the like, I want to go into details of what are all the specs of MLOps. There are really good books. If you want, like, we can talk later about the good literature where to start with MLOps. But this is a way how can you set up everything for yourself, and then you can automate the whole process so you don't have a lot of places for user error. I'll just use this on this schematic, how one MLOps workflow can look like. So you always start with the requirements, and this is the first and most important step is workflow design. So you use workflow design, you set with your team, that the process usually takes 1 or 2 days, and then you design how your team is going to function and how you're going to set up everything. So, for example, you will figure out what you have. So, for example, we have pings from the users. The first part is to figure out what are the features that we are going to use. Is that going to be a raw ping, or we are going to group pings together, or what we are going to do with pings? That's the process of feature engineering. And that dictates how the model is going to be trained. And then you can figure out what are the metrics for your model success. So there are different machine learning metrics that you can implement to see how everything works and how your model performs in production. And then there is the process where you need to sit with the operations side and software engineering side to figure out how your model is going to integrate in the pipeline. So, for example, the most expensive models are the models that are making predictions in real time, but maybe you don't need that. You can do batch predictions, so you have a job that runs once a day, and that's much more cheaper options, but that's the thing that you need to sit down in advance and figure out with the operations part, how are you going to put models in production. And then when the model is in production, you have the inference phase where the model is making predictions, and you're collecting that production data, and you can then go back to the labeling of that data and retrain your model and enrich your training set. So machine learning projects are not static thing. As other software engineering projects, you need that iterative process to retrain your model on the fresh data that comes in. Also, there are like seasonal changes in the data. For example, during the summer, people travel more, so you have less interactions in the main cities, but on the winter, when the people come back, you have more interactions, and you might need to tweak your model for different scenarios. I'll finish with some objectives that I found really useful when setting up MLOps. So there is no single recipes for success when setting up MLOps pipelines, But these are some things that should be taught about in advance before starting your project. I'll maybe just say about scalability and transparency of the project. So a startup company might be bought. So you have 1 or 2 data scientist team trying to later integrate in a team of 10, 15 people. If the MLOps pipelines are not set up in a scalable way, you might be stuck with a large onboarding process for new people that are coming in. And this is also another thing, transparent pipelines. Like you shouldn't silo knowledge at 1 or 2 people. Like you should try to document all the processes of the MLOps. So later when you try to onboard new people and try to scale your team from like 2 to 15 people, that's much easier. And I'll just finish with this one, collaborative. It's a really good thing that to sit with all the people involved and talk about different aspects of the pipeline, and you should find the owner of each part of the pipeline. So that should be like one expert for the part of the pipeline, but everybody should know at least on a high level how the pipelines work. I'll leave it. I'll finish here and open it for questions. So I know that this is a really high level overview, but I see the one question in behind, and we can go maybe into some details about. If you're interested, we can talk about now or later.
I hope audience excuse me for specific question, but can you name the minimal tool set for the kickstarting machine learning project?
So minimal
yeah, tool set for starting the like MLflow, Airflow.
So if you can start your ML, like my first machine learning project for a company, we just had a local machine. Our data set was really small, so we didn't need to, like the data set was few gigabytes, and we used, like we didn't use, but we should use ML flows, and then just that's the basic thing that you need. And of course, like you need a set of tools for modeling, but there are a lot of libraries for sklearn, TensorFlow, whatever like your model is. Yeah, and one thing is like you need a person that understands how the models work. Like I was working in other company where the results were much more sensitive. So if we make an error here and there with our models, it's not the end of the world. But for example, if you're working in a medical startup, you should really know what your model requirements are and what are the inputs and outputs. So you shouldn't try to do something that's not required. Yeah, but ML flows is a really good option. And also, like if you're using AWS, there is a relatively cheap distributed version of their implementation. I think it's called machine learning workspace that you can use, or Azure has their implementation of ML flow.
You mentioned that one of the projects you worked for failed to reproduce, and what are other I don't know, cornerstones you could name aside from logging?
Well, one thing that should be in mind when working with the one stepping stone that was also a problem, like we had a really optimistic initial results from our data, and like we got 80% accuracy, and we were, wow, we did that in like 15 minutes. But getting to 90% of the accuracy was 2 months of work. So you should be prepared that you can't do anything overnight. So that's one. And one thing also, like this is more specific for data science, leaking your test data to your model while training, especially if you're working with graph neural networks, it's really easy to leak your data, your test data into your training set. So those are like, yep.
So I expect the answer would be yes, but does it mean that you are at the moment working with the graph neural networks?
I'm not at liberty to say that.
Okay.
Yeah.
Fair.
Okay, one more here.
How do you know that you created a good predictive model?
If it solves the business problem, like if your customer is really satisfied with your results, then that's the ultimate goal. Like in academia, it's be better than the previous models or have high accuracy. But when you're working in the industry, like your customer needs to believe your model.
So there is not some like margin or related to percentage. No.
No,
No,
like
it's-
when I was working in some agri-tech stuff, they were satisfied with like 60% accuracy, which was just small margin of over random. So it's all industry dependent.
Thank you.
Can you go to the previous slide?
The previous one?
Yep. You have 15 words here. If you can choose only 2 for your projects,
Uh,
what will it be?
Scalable and transparent.
Thanks.
What is the frequency of retraining of your most frequently retrained model? And deployment also.
Oh, it's like the pipe. We haven't still finished our pipeline till the end. So in this company, like I can't answer for us, but it all also depends on the date. Like in the previous company, it was 6 months, for example.
Thank you. One more here.
Hello, thank you for your speech. Do you have some bad experience that you can share? For example, how not to start or which mistakes you can avoid from the beginning?
One mistake was I was tasked to create an anomaly detection model for something, and I spent a lot of time building a machine learning based model and trying to put AI into something. At the end, 10 lines of code were like, if else, if some statistic larger than this, then it's an anomaly or not. Sometimes classical algorithms can solve your problems. Like, don't try to stick ML everywhere. You can call it AI, that's okay, but it's not like ever. That's one thing. And also, like, if you have a junk data set, like junk in, junk out, that's like data science 101. You need to have good data to build good models.
Okay, thank you.
You mentioned 5 roles that are probably present at your team. Who of these people do work on MLOps, or do they all contribute in some part?
Usually, like that's distributed, so everybody should own a part of the MLOps procedure. Like it's not that, like some teams, not here, but some teams have a dedicated MLOps person. Like here, it's distributed. So, no.
Because I did a couple of times see like an MLOps engineer, but it looks a bit weird because then you take out the responsibility is someone else's.
Yeah, I worked once for 3 months as an MLOps engineer, and then my job was done, so I didn't have that job anymore. Yeah, like when you set up the pipelines, you maybe just like sometimes if you're growing a lot, you need a dedicated person and changing a lot. But if you're a smaller team, then probably you need somebody to set up everything, or even you can set like it's just reading a bunch of documentation. This design, workflow design, that's the most important part of MLOps. Sitting down with people and deciding how are you going to do MLOps.
Okay, one more here. This gentleman was first in the
Yeah, can I see last slide with words?
This one?
Yes. I'm not really understand about scalable in topic of MLOps.
It's scalable in the terms that your workflow should enable your team to grow from 2 or 3 people to 15 people. It's not kind of like, it's not scalable in terms I'm getting from 100 megs of data to terabyte data. It's not that kind of scalability. It's scalability in terms of people that are working on your ML pipelines. So you should have a process that's that it will enable your team to grow.
Okay, well, thanks you.
And one more question from my DevOps background. Do you use, if you are talking about kickstarting the project, do you use some techniques to bootstrap the project, like to start with some already prepared tools, or every project is unique?
It's unique, but there are like some tools that you can reuse from project to project. Like you shouldn't build your ML pipe or DevOps or MLOps pipeline from scratch. Like if you like, for example, if you have a done product that has its own DevOps cycle, you should add to that cycle, not create everything from scratch.
Yeah. And how do you reach this kind of scalability when you team grow from 2 to 15 person?
Good documentation and good communication and transparency, like not siloing in. So when a new person comes, like he or she should onboard with a more senior staff member, and that person should be taken through all the steps that are like that person doesn't need to understand all the single details, but should know how the pipeline works from the beginning to the end.
Have you ever grown a team from like 1 or 2 people to more?
Like I was at a company that was growing team from 2 to 6 people and then integrating in a large corporation. So I went through that process. It was a nice and also painful process. So it's not easy to do that.
Okay, looks like we're done. And then if there are no more questions, please big round of applause for Stefan.